Hello KCET 2025 aspirants, welcome to 60 out of 60 KCET Chemistry 2025 series. So as you all know, we have started a series where we are going to cover every concept that is going to be asked in your KCET examination, as well as we are going to solve all the PYQs and practice a lot of questions so that you can master these topics and hit that perfect 60 score. Right? So yes, in today's video we are starting a brand new chapter, that is chemical kinetics of PU2. Okay, so a very high weightage and important topic, and in this video we will be covering the rate of a reaction and the factor concentration in detail. Okay, so remember, this is the video from where like 90% of kinetics questions will be asked. Whatever number of questions are asked from kinetics, we'll also see that, but majority of the questions will be asked from this concentration part. Okay, so I request every one of you to sit with a notebook and a pen and note down all the important formulas and all important concepts. Okay, now one more request to all of you, please join our WhatsApp channel. It is for your good, that because all the notes of these PDFs, like all the PPTs notes and class notes, your PYQs and different questions, practice, solutions, everything will be provided in our WhatsApp channel. Okay, so please join our WhatsApp channel, and so that you do not miss any of these important details. Okay, now let's get started. All my champions, be ready with your notebook and pen. Let's get started now. Okay, so first of all, I'll tell you how am I going to cover this particular topic, how many lectures will be there, on which lecture which topics will be covered, everything first I'll tell you, so that you can have a clear understanding that in how many videos or how many lectures you will be able to cover this topic. So the first part here is rate of a reaction. Okay, second one, factors affecting rate of reaction. Third, effect of concentration. Remember, this effect of concentration is a very vital topic. Okay, next we have methods to determine order. Okay, now coming to part 2. Okay, so today we are going to cover part 1. In the next class we will cover part 2, but I'll tell you what topics we'll be covering there. Effect of temperature, effect of catalyst, and collision theory. Okay, so these 3 topics are for your part 2 and these 4 topics are for your part 1, that is today's video. Okay, now coming to the weightage, year-wise weightage of this particular chapter. How many questions have been asked in the past years? So you can see consistently from 2017 to 2023 questions have been asked. Then 21-22 4 questions, again 23-24 3 questions. So roughly I can say that you can expect 3 to 4 questions from this particular chapter, right? You can expect 3 to 4 questions which can give you 3 to 4 marks in your KCET examination. And remember, scoring these 4 questions will be very easy if you follow these 2 videos that I am going to make on kinetics. I will be covering every type of question and every PYQs, like every types of PYQs, so that you feel confident on this particular chapter. Okay, so yes, now let's get started. First of all, the chemical kinetics part 1. So as I told you, we will be discussing these concepts today. Rate of the reaction, factors affecting the rate of the reaction, effect of concentration. Now in rate of reaction, what all things we are going to cover? Average rate, instantaneous rate, and differential rate equation. Okay, next, in effect of concentration, there are so many topics we are going to cover, that is rate law and rate constant, order and molecularity, integrated rate equation, half-life, and pseudo first order reaction. Okay, so I missed here one thing that you are going to discuss, methods to determine order. Okay, methods to determine order of a reaction. Okay, this part is also there. So we have, today we are going to cover rate of a reaction, in that these 3 topics will be there. Then we are going to cover factors affecting rate of a reaction, in that we are going to discuss the factors, and then we have effect of concentration. Remember, this is very important topic. These all the subtopics that I have discussed under effect of concentration, you can expect one question from these 5 topics. 1 to 2 questions definitely are going to coming from these topics. Okay, so very important. And next topic we are going to discuss is methods to determine order. Okay, so yes, now let's get started with the first topic, that is rate of a reaction. Okay, coming to this, rate of a reaction is of 2 types, average rate and instantaneous rate. Okay, what is the meaning of this? So see, average rate is measured for a certain interval of time. Like for example, you started a reaction, okay, and then you kept it for 10 minutes, and after that you came and checked the reaction. What is the rate of a reaction in this? When you measure it for a certain interval, a particular interval of time is there, those rate is called as average rate, okay, and it is represented by this triangle, that is delta, okay. Now coming to instantaneous rate, what is the meaning? From the word only you can understand what is instantaneous rate. Measured for a particular instant, okay, at that particular time. Like for example, you started a reaction at 10 o'clock, okay, 10 am you started, so you want to know at 10:10 what is the reaction, what is the rate of the reaction, clear? So that is called as instant, at a particular instant, and it is represented by d by dt, okay. Now before going to these all things, I also need to tell you what is rate of a reaction. Rate of a reaction is nothing but speed of a reaction, okay, how fast is the reaction. Now how do we calculate this? So this is nothing but change in concentration, okay, change in concentration by change in time. So I can I'll write like this: change in concentration by change in time, okay. Now whether I need to put delta or I need to put d by dt, that depends whether I want to calculate average rate or I want to calculate instantaneous rate. But basically, if you have started a reaction, what is the change in concentration divided by the change in time is called as rate of a reaction, clear? Okay. Now let us go to, this is very important here, what is this? Graph, okay. Now let us understand. Now one thing I'll tell you first before here, when you do a graph for a rate of a reaction, what will happen? See, with time, suppose the reaction is there, R is getting converted to P, right? With time what will happen? As time proceeds, the reactant concentration will decrease because it is getting consumed, right? So graph for that will be like this, okay. Reactant concentration will decrease, and with time the product concentration will increase, right? Product concentration, if it is increasing, it is becoming, the graph should become like this. So I can write R here and I can write P here, right? Reactant concentration is decreasing and the product concentration is increasing, clear? Okay. Now let us go to this graph and understand average rate and instantaneous rate in detail, okay. So I hope that this graph is visible to you, right? So now this is what? This graph is for what? Can you guess, reactant or product? Yes, just now I showed you. So this is for reactants. The graph is for reactants, and this graph where the graph is increasing, this is for products. Okay, now let us see. Now here what happens, if you see the concentration we need to check, okay. Now see, very carefully you have to see here, that if I want to calculate the average rate, so what I have done, I have taken this time interval, okay, where it was R1, and I have taken this time interval. Concentration here is R2. With time, the concentration has decreased, right? Now for R1, the time was T1, okay. At T1, the concentration is R1, and at T2, the time is T2. At for concentration R2, the time is T2. Now this time interval is called as delta T. Okay, this time interval is called as delta T, and this change in concentration is called as delta R. So the average rate is equal to minus delta R by delta T. Now why this minus has come? This is because suppose you see what happens, suppose you started from 0, right? So 1, I'll just write like this, 2, and this is somewhere 3, and this is 4, for example. Right? So we are taking the final concentration minus initial concentration, and the rate of the concentration of the reactants will decrease. So definitely the final concentration will be less, right? So I'll get 3 minus 4. But rate of a reaction cannot be negative. So to cancel out that, we have a minus here. So remember, minus has to be always used with reactants only. Okay. So I'll get R2 minus R1 divided by T2 minus T1. Okay. Now coming to instantaneous rate. What is instantaneous rate and how can we calculate that? See, at this particular time T, Okay, I want to calculate the rate of a reaction. So what I have to do is, this graph is there, right? You need to draw a tangent here, okay, and then you have to calculate the slope of that tangent. Okay, in that way we can calculate the instantaneous rate. So I can get that at this particular time what is the rate of a reaction, and in that case how do we represent R instant minus dr by dt? We do not use this delta. Why? Because the time interval is very small, right? So we need to use minus dr by dt. Okay, and this will give you the slope of this tangent, will give you the instantaneous rate. Getting? Okay, now coming to the product concentration graph for the product side. Okay, so here if you see this one, okay, this graph is for the products. Now what happens, let us calculate the average rate and instantaneous rate. Okay, now you see this is T1. For T1 the product is P1. Like at that time the product is P1, and at time T2, because the product is growing, so that at that time it is P2, right? So now if I want to calculate the average rate, it is delta P by delta T. So here you can see what is the final concentration P2 minus the initial concentration P1 divided by, for P2 the time is T2 and for P1 the time is T1, right? So P2 minus P1 by T2 minus T1. Getting? So we have got the average rate, that is delta P by delta T, and then if we want to calculate the instantaneous rate, right? For instantaneous rate what we can have, this particular slope. Okay, the graph for this will draw a slope that I want to calculate the rate at this particular time T, instantaneous time, instantaneous time, that is T. If I want to calculate the slope of this graph, will give you the instantaneous rate, the slope of this tangent. So that is dp by dt, and here you see positive, you will get a positive term. Okay, I hope this is clear. You need not, in exams questions will not be asked to calculate from the graph, so you need not worry like how to draw the tangent and how to calculate slope, nothing like that. You just need to understand a very basic difference, that average rate means at a certain time interval and instantaneous rate means at a particular time. Getting this much? If you are understood, that is well enough. Okay, now coming to the question 1 of the question here, which of the following statement is correct? Okay, let us see what we have understood. The rate of a reaction decreases with the passage of time as the concentration of the reactant decreases. Okay, this question will do just after 1 second. This question I'll come back to this question little later. We will first discuss the factors, then we'll do this question. Okay, okay. Now coming to, there is something called as differential rate equation. Okay, what is this differential rate equation? Now let us understand. So differential rate equation is a equation to represent the rate of a reaction. How to write it, I'll tell you. So rate is equal to, okay, you have to use this concentration, that is minus 1 by 2 d of N2O5 by dt. Okay, is equal to, so this is a reactant, so I will use negative sign here. The stoichiometric coefficient will come in denominator 1 by 2, and d, that is change in concentration of N2O5 divided by change in concentration of time. Okay, now coming to this one, here this is product side, so I will use plus. So remember, negative is for reactant, positive is for product. So 1 by 4 of dNO2 by dt, okay, is equal to 1 by, we don't have 1 by 2 here, so dO2 by dt. Two things you have to remember, what students generally do mistake here. For reactants, you need to use negative sign. For products, it is positive sign. That is the first thing. Second, you have to check the stoichiometric coefficients. They should come in like denominator, and then this is equal to rate of a reaction. This you should remember. Now I want everyone to try this question. Stop the video or pause the video and write this equation and then check with me. Okay, let us try. So what I can write, rate is equal to minus dN2 by dt. Okay, then I'll have minus 1 by 3 dH2 by dt. Okay, then I have plus 1 by 2 dNH3 by dt. Okay, minus dN2 by dt equal to minus 1 by 3 dH2 by dt equal to plus 1 by 2 dNH3 by dt. Getting? So I hope you can now understand how to write these equations. Okay. Now coming to solving this question, which of the following expressions is correct for the rate of the reaction given below? We'll do the same exercise what we have done, and then we need to check this one. Okay, so I'll write from the left hand side. So I can write that rate is equal to, okay, minus 1 by 5 dBr minus by dt equal to minus dBrO3 minus by dt, okay, equal to 1 by 6 dH plus by dt. Okay, here also minus will come. Now this is equal to, now I am going to product side, so plus 1 by 3 dBr2 by dt, okay, then that is equal to plus 1 by 3 dH2O by dt. Clear? Now what happens here? We need to see the options are for dBr by dt and dH by dt. So we need to relate Br minus and dH plus. So I'll take these two equations separately. This one, okay, and where is H plus? This is H plus, right? So I'll write these two as separately, and I'll write minus 1 by 5 of dBr minus by dt, okay, is equal to minus 1 by 6 of dH plus by dt. Clear? Now let us solve it. dBr minus by dt, what I can take? I can this multiply 5 here, cross multiplication. So I'll get 5 by 6 of dH plus by dt. Okay, so this is my answer. Now let us search for where we can get this one. So yes, dBr minus by dt is equal to 5 by 6 of dH plus by dt. So the correct answer for this question will be option number C, right? Option number C is the correct answer. Okay, now let us move to the next question. For a chemical reaction 2x plus yz, the rate of appearance of Z. So rate, now here also I want to tell you two important things that you have to remember. The rate of appearance, okay, means rate of formation. Now tell me, reactants are getting formed or product is getting formed? Product is getting formed, right? So for the rate of appearance, term is used for products, okay, and rate of disappearance. Rate of disappearance means that is something which is consumed. Okay, now reactant is getting consumed or product is getting consumed? Reactant, right? So the rate of disappearance is used for the what? Is used for reactants. Clear? Okay, now let us do this one. We can write for this reaction minus 1 by 2. So I'll write rate is equal to minus 1 by 2 dx by dt is equal to minus dy by dt, okay, is equal to plus dz by dt. Okay, now we can solve it. Okay, the question is given as the rate of appearance of Z, means dz by dt is given to you as 0.05 moles liter inverse minute inverse. Dz by dt is given, and the question is asking you for rate of appearance of X. So there is a relation between, or the question has given us a relation between X and Z, right? So we'll write that here. So I can write 1 by 2 of dx by dt is equal to dz by dt. Okay, so I need to calculate the rate of appearance of X, right? So I can write it as, rate of disappearance of X. So dx by dt will be equal to 2 times of dz by dt, right? What I have done, just multiplied this to cross multiplication. So 2 into, what is the value of dz by dt? 0.05, right? So if I multiply this one, I will get 0.1 mole liter inverse minute inverse, right? So the correct answer for this question will be option number C. Clear? I hope that everyone is getting this one. Okay, very easy. Just you need to, first of all, first step is write the differential equation for the whole reaction. Okay, after writing that, see what is the, which two reactants have been connected, that you write separately. Okay, then you need to find out which is to be calculated and then arrange the equation, substitute the values and do the calculation. Okay, fine. Now let us go to the next one. Factors affecting rate of a reaction. Okay, so what are the different factors? So there are three important factors. First factor is your concentration, second factor is temperature, and third factor is catalyst. Okay, so these are the three important factors which affects the rate of a reaction. Now what happens in concentration? So if concentration will increase, okay, remember, if concentration increases, then the rate of the reaction also increases. Okay, if concentration increases, the rate of the reaction also increases. Now coming to in temperature, what happens? If the temperature increases, then also the rate of the reaction increases. Now what is the reason for that? So just now, for now you understand. When we'll explain this in detail, at that time I'll tell you in detail. But what happens is, you have to remember, when we increase the temperature, the more number of molecules have energy to get converted into products. Okay, so I'll write for now you, when we increase the temperature, what happens? More number of particles have energy to form products. Okay, more number of particles are having energy to form products, so that is why what will happen? More number of particles will get converted into products and the rate of reaction will increase. Now coming to what is the catalyst here. So here I will read it for you. Positive catalyst increase the rate of the reaction. Okay, positive catalyst increase the rate of the reaction. I hope you have noted down here, so I'll rub this so that we can read it. So positive catalyst increases the rate of the reaction. So you can understand, if we increase the concentration, that then also reaction will increase, rate of reaction will increase. If you increase the temperature, then also rate of reaction will increase, and if you use catalyst, then also the rate of the reaction will increase. Clear? Okay, now we will go to those two questions that we have left in the first some time before this question. Which of the following statements is correct? Okay, so let us solve it. The rate of a reaction decreases with the passage of time as the concentration of the reactant decreases. Okay, is this statement correct? Rate of a reaction is decreases with passage of time as the concentration of the reactants decreases. Okay, I think that can be a correct statement. Concentration of the reactant will decrease, so rate of the reaction will also decrease. Next, coming to this one, the rate of a reaction is same at any time during the reaction. No, this statement is wrong. The rate, as I already told you, rate depends on concentration, right? And concentration decreases with time, so rate will also decrease with time, right? So that is why rate cannot remain constant. Next, the rate of a reaction is independent of the temperature change. No, just now we discussed that if temperature will increase, rate will also increase, so that is why this is also a wrong statement. Now coming to the last one, the rate of a reaction decreases with the increase in concentration of the reactants. So it is telling that if the concentration will increase, then rate will decrease. Again, this is a wrong statement because it is directly proportional, right? So that is why I can eliminate this also. So the correct answer for this question will be option number A. Okay, fine. Now coming to the next question here. The concentration of the reactant changes from 0.05 moles to 0.01 mole in 10 minutes. Okay, the rate of the reaction is, okay, so here you see, this question is from your average rate concept. So how, that is the formula of average rate. I have written that average rate is equal to, right, R2 minus R1 by T2 minus T1, right? Now what is the change in concentration? From 0.05 to 0.01, right? And we have written for reactant it has to be a negative sign. So you remember this graph, where is that graph? It is, see, average rate is minus dr by dt, right? Minus delta r by delta t. So I can put here minus, okay, what is the final concentration? 0.01. What is the initial concentration? 0.05 divided by 10. Okay, so now we will have is 0.004, right? So it will come minus, this minus and this minus will become negative. So I'll get plus 0.004 moles, and here it is minute, so mole minute inverse. So the correct answer for this question is option number B, 0.004 moles per minute. Okay, fine. Now we have done this one, we have discussed the factors also. Okay, now coming to the next concept, that is we are going to discuss another question here. Increase in the temperature increases the rate of the reaction. So just now we discussed that increase in temperature will increase the rate of the reaction. What is the reason behind this? So this will be more clear when I discuss the effect of temperature, when I discuss that topic. But let us see the question now. Total number of collision decreases, this is wrong. Pressure of the system, there is no relation here. More molecules have enough energy to collide. So just now I explained you, when the temperature increases, the particles, the reactants get more energy, okay, and they get more energy to get converted into products. So that is why this is the correct statement. Okay, the activation energy, this is also not the correct answer. Again, this statement will be more clear when we discuss the effect of temperature in detail. Okay, fine. Now coming to the next topic, the very important, most crucial topic and the major topic from where the questions have been asked is your effect of concentration. Okay, this is very crucial topic. Coming here, rate law and rate constant. Okay, so what all things that we are going to discuss in this particular topic? First is rate law and rate constant, then we are going to discuss order and molecularity, then integrated rate law, then half-life, and then lastly we'll be talking about pseudo first order reactions. Okay, fine. So let us come to the first one, rate law and rate constant. What is rate law and what is rate constant? Okay, so now you see, rate law is nothing, very simple thing. Rate law is an expression in which the reaction rate is given in terms of the molar concentration of the reactants, with each term raised to some power which may or may not be same as the stoichiometric coefficients of the reacting species in a balanced chemical reaction. Ma'am, what is such a big statement you read here, right? Very simple, I will explain you. See, we'll leave this definition, nowhere definition is going to be asked. We'll see this example. So this is a reaction, okay? AA plus BB gives CC plus DD. Now what is it? This rate law tells that the rate of this reaction, okay, will be proportional to the concentration of the reactants raised to some power x and y. This x and y may or may not be equal to A and B, which is their stoichiometric coefficients. So what I am saying, x may or may not be equal to A and y may or may not be equal to B. Getting? Okay. Now to remove this proportionality constant, okay, to remove this proportionality, what we do, we need to multiply a constant, and that constant is k. Now what do we call this k? K is called as rate constant. Okay, k is called as rate constant. Okay, now coming to what will be the unit of this k. So you see here, I'll just write like this, rate is equal to k into some concentration to the power of x. I'll just write it like this, or let me make it n. Okay, for more convenience I'll use the letter n. Okay, now what is the value of k? It will be rate, okay, to the a by n. Okay, now what is rate? Moles. Unit of moles is what? Concentration. Unit of rate is concentration by time. So concentration is mole liter inverse, time that is second inverse. Then again concentration, moles liter inverse to the power of n. So here what I can use, mole liter inverse second inverse, I have mole to the power of n, liter to the power of minus n. Okay, now if I solve this, what I'll get? Moles 1 minus n, liter n minus 1 second inverse. Okay, so that is the unit of k. Okay, unit of k can be mole 1 minus n, liter n minus 1 second inverse. This is what you need to note down. Now what is n here? Okay, I'll talk about this. What is x and what is y, we are going to discuss it in detail. Okay, Fine. Now let us go to the next. All of you clear what is rate law? Nothing fancy it is. It is very simple thing. Rate law is just an expression. What does this expression tells us? How the rate depends on the concentration, okay, and the concentration of the reactants, how the rate depends on the concentration of the reactants, and these reactants are raised to some power x and y. This x and y may or may not be equal to A and B. Okay, it may be also equal, it may not be equal also. Okay, now to remove this proportionality we need to multiply a constant. That constant is called as rate constant. So just that we multiplied and here we can calculate. Clear? Units of K clear? Okay. Now let us go to the next thing. A question is here for you now. Rate law of a reaction A plus 2B gives C is found to be this one. Okay, they have given you the rate law. Now concentration of the reactant B is doubled. Keeping the concentration of A is constant. The value of rate constant will be. Okay, very important question. See, one more thing I'll tell you. This rate constant, okay, K, it depends only on temperature. It does not depend on any other factor. Whether you change the concentration or not, rate constant will remain same. It will only depend on temperature. So the question is telling that we have this reaction A plus 2B is giving you C. Now rate is equal to K into AB. You have changed the concentration of B and you made it double. Okay, now the question is telling what will be the rate constant. So remember, when the concentration changes, it doesn't affect the rate constant, it still remains the same. So what will be the answer for this question? Option number A. Okay, the rate constant will be the same. Got it? So now for a reaction, rate is equal to KAB square if the volume of the vessel is reduced to half the initial volume. The rate of the reaction would become dash times the original rate. Okay, now let us understand this question. So there was a container when you are doing this reaction. Okay, so what they did is the volume of the volume changed and the volume was reduced to half. Okay, then what it will be the effect on the rate of the reaction. So now for this you need to know one very important thing. When I am talking about concentration, we are meaning the term is molarity. So what I can say, molarity formula, just now we are discussing solutions chapter, number of moles by volume. So what you say, volume is decreasing, molarity will increase, right? If volume is reduced, molarity will increase, or I can say that concentration will increase. Let us do this question now. So R is equal to K into A B square, right? So if the volume has been reduced to half, if the volume is reduced to half, then can I say, I can write it like this, the concentration has increased by 2 times, the concentration has increased by 2 times. So I can write the new rate, okay, because I am changing the concentration, so rate will definitely be affected. So it will become 2A and this will become 2B square, right? So now let us solve this. I'll get K, I'll take this 2 out, 2A, okay, and this is 2 to the 4, so I'll get B square. So total I'll get 8 K A and B square. Okay, so now this is R dash. Okay, now they are asking what is the, how many times it has increased. So now if you see what is this KAB square, this is your initial rate, right? So I can write R dash is equal to 8R. So what is this? When you are changing the concentration, the new rate has become 8 times the initial rate. Okay, so the answer here will be option number D, that is 8 times. I hope you are getting this one. So the previous question they asked that rate constant is not affected by the concentration, but rate depends on the concentration. So when you have reduced the volume to half, the concentration has doubled, right? So if the concentration has changed, the rate will also change. So how many times the rate has changed? It has increased by 8 times, right? Okay, so what I can say, if you are increasing the concentration, rate is also increasing, right? Okay. Now do one more question. For a reaction 2A plus B gives D plus E, the following mechanism has been followed. The rate of the reaction is. So here one more thing I want to tell, that here one point we will add, rate, okay, depends on the slowest step of the reaction. Okay, so when we are writing the rate law, If the reaction consists of multiple steps, there are 2-3 steps, then there will be one step which is the slowest step. So the rate will depend on this slowest step. Okay, so if I consider this is the one step and this is one step, then on which step the reaction will depend? On this one, right? This is the slowest step. Okay, so I can write rate is equal to K into concentration of A into concentration of B, right? Now here, if there is no information is given, so we can consider this is 1A, this is 1B, so this is also 1. We can consider because no other information is given to you. Okay, so now here the answer will be option number B. Rate is equal to K into A into B. Getting? Okay. Let us see one more question. Okay, the rate of a first order reaction X to P is this much when the X is this much, the rate constant is. So it's a first order reaction, so I can write rate is equal to K into X, okay, because the X is the reactant, to the power of N. This is rate law. So here first order means I can write X to the power of 1. Okay, now let us put the value. What is the value of rate? Rate is 7.5 into 10 to the power of minus 4, right? And what is K here? K we need to calculate. Now what is the this one? 0.05, right? Now we can divide this one on this side. 7.5 by 0.05 into 10 to the power of minus 4 is equal to K. Okay, so now if you solve this, we will be getting around 15 into 10 to the power of minus 3. So the correct answer for this question will be option number C. Okay, again this is also very direct and simple question. Let us go to the next topic here, that is order and molecularity. Okay, okay, now in the rate law you have seen that R is equal to K into A to the power of X and B to the power of Y. Then what is this X and Y? What we call them? So there's a name for that. We will call that X is order. X is the order, okay, with respect to A, and Y is the order with respect to B. Okay. Now if they ask what is the order of this overall reaction, the reaction order will be X plus Y. Order of A is X, order of B is Y, order of the reaction is X plus Y. Okay, so what is order? The sum of the powers of the concentration terms of the reactants in the rate law expression is called the order of the chemical reaction. Getting? Okay. Now what is this order used for? What is it required? See, we have understood that when we increase the concentration, rate will increase. Okay, when we increase the concentration, rate will increase. But how many times the rate will increase if you increase the concentration? That is what is told by the order. Getting what I am saying? So what is the significance of order? It tells that how the reaction, how the rate of reaction will change, how the rate of reaction will change if the concentration changes. Okay, if the concentration changes, then how the rate of the reaction will change, that is what is given by the order. Now here you remember, see, if the concentration is doubled, okay, and at the same time rate is also doubled, then we call it a first order reaction. I'll tell you this in detail, but just now let us discuss. If your concentration is doubled, okay, but rate no change, then we call it a zero order reaction. This is first order reaction. If concentration is doubled, okay, and rate has become 4 times, okay, then we call it a second order reaction. Getting? So this is how, so see here also in every, see, every case, in every case you are doubling the concentration. Okay, in every case you have doubled the concentration, but based on the order of the reaction we see different changes. If it is a second order reaction, rate will become 4 times. If it is zero order reaction, there will be no change in the rate. If it is a first order reaction, then there will be the rate will also become double, right? So what is happening when you change the concentration, how the rate will change, that is what is determined by the order of a reaction. Getting? Okay. Now So here, as I told you, this is suppose a reaction and this is the rate law for that, then order of the reaction will be x plus y, order of A is x, order of B is y, okay, that we have already discussed. Next, order of a reaction can be 0, 1, 2, 3 and even a fraction. So order can be anything, 0, 1, 2, 3 or even a fraction. Now order tells us how the rate changes when the concentration changes, okay, that is what I explained you. Concentration, if you change, rate will change and rate will increase. If you increase the concentration, rate will increase. But how much it will increase, how the change will happen, that is what is given by the order of the reaction. Okay, very, very important concept. Okay. Next, coming to something called as molecularity. Okay. So now molecularity is what? This is also very important. The number of reacting species, okay, taking part in an elementary reaction. I'll tell you what is elementary reaction, which must collide simultaneously to bring about a chemical reaction, is called as molecularity of a reaction. See, now reactions are of two types, okay. Reactions are of two types. One is complex reactions, okay, and another is elementary reactions, okay. Now what is complex reactions? Complex reactions are those reactions which occur in more than one step, okay, and elementary reactions are those reactions which occur in one step, okay. So now what happens here, the number of reacting species in this elementary reaction, how many species are reacting or colliding with each other in such a way that they can bring about the chemical reaction, that is called as elementary reaction, that is called as molecularity of a reaction. Now see, for example, in this particular reaction, if you see, there is only one reactant, right, only one species is reacting, so molecularity is 1, clear. Now if you see here, 2HI gives H2 plus I2, so how many molecules of HI is there? 2 molecules, so number of reacting species is 2, so molecularity will also be 2 here. Next, coming to the third reaction, 2NO plus 1O2, right, so total number of species reacting is 3, then molecularity will also be 3 here, okay. So you are getting, when the reactions are changing, when the number of reactants, based on the number of reactants, we can tell molecularity of a reaction. So here you should remember that molecularity cannot be fraction, molecularity cannot be fraction or 0, okay, but order can be 0 or fraction, okay, but molecularity cannot be fraction or 0, okay, fine. Let us do this question. Okay, one more thing I want to add regarding order. Here, how do we determine, how is order determined? So order is determined experimentally. Please remember this one. What do you mean by experimentally? See, suppose I have a reaction, okay, suppose I have this reaction, A plus B is undergoing C plus D. Now if I will change the concentration of A, I will make A double, and then I will see what is the effect on the rate. Then I can say that if I change A but still there is no change in rate, then I can say that with respect to A, the rate is 0 order. If I double the A and I observe that rate has also become double, then I can say that with respect to A, the order is 1, right. If I have doubled the concentration of A and the rate has become 4 times, then I can say that with respect to A, the order is 2, right. So how can I tell the order of the reaction? That is by doing experiment, okay. So remember, order we cannot tell randomly or just by seeing the reaction, because I told you this A and B may or may not be equal to X and Y, right. So that is why order is only and only determined experimentally. You have to do the experiment and then you have to tell the order of the reaction, okay. But molecularity, by seeing the reaction only we can tell the molecularity. It need not be determined experimentally, okay. Okay. Now let us do this question. Order of which of the statement is correct, you have to find out, right. Correct statement we need to tell. Okay. Order of a reaction can be a fractional number. Yes, we have just discussed, it can be a fractional order. Order of a reaction is experimentally determined. Okay, it is saying not correct, okay. Please remember, not correct. So this statement is correct. Order is experimentally determined. This is also correct. Next, order of a reaction is always equal to sum of the stoichiometric coefficients of the reaction in a balanced chemical equation. So I told you that order may or may not be equal to stoichiometric coefficients, right? It is not that it is always equal to sum of the stoichiometric coefficients, right? So this statement is your incorrect statement. Next, coming to the order of a reaction is the sum of the power of the molar concentration of the reactants in the rate law expression. Yes, in the rate law expression, the sum of the powers of the reactant terms, that will be equal to order of the reaction, right? So the correct answer, the incorrect statement is option number C, right? So the correct answer for this question will be option number C. Okay. Okay, now let us go to something called as integrated rate equation. What is integrated rate equation? This is also very important concept. So still now what all things we have covered, let's have a recap quickly. First we saw types of rate, average rate and instantaneous rate. Then we saw differential rate equation, right? And we did some problems based on this. Second thing we saw is the factors affecting rate. So I told you 3 factors. First is concentration, second is temperature, third is catalyst. Okay. Now we are studying the concentration factor in detail. So in this first concentration factor, the first topic we studied is rate law and rate constant. What is rate law? Rate law is an expression which tells that how rate depends on the concentrations, right? Then we studied what is this rate law. Okay, we solved some questions from here. Then we discussed what is order and molecularity, right? Now we are going to discuss the third topic under concentration, that is integrated rate equation. Okay, integrated rate equation. Now what is integrated rate equation? See, integrated rate equations are again expressions that express the concentration of the reactants in a chemical reaction as a function of time. Means, see, if you see rate law, what is rate law? R is equal to K into A to the power of X and B to the power of Y, right? It is telling you the relation between rate and concentration, but there is no involvement of time, right? There is no involvement of time here. So if I want to express rate also in terms of using time as a function, time should also be considered, then we have to talk about integrated rate equation. Getting? When I talk about rate and I want to consider time as a function also, then we need to consider integrated rate equation. Okay. So now integrated rate equation we are going to study for 2 orders, that is 0th order and 1st order. Okay. Now what is the use of studying this integrated rate equation? What are the applications of integrated rate equation? See, to calculate how long it takes for a reaction to progress. Suppose I told you it is involving the function of time, right? So now suppose you have started a reaction at 10 o'clock. Okay, you have a reaction is there, A is giving you B. You started this reaction at 10 am, okay, and the A concentration you took is around like 4 moles, 4 molar, okay. Now you want to see that after 30 minutes how much A is left after 30 minutes, right? What is the concentration of A? If you want to calculate this, then we need this application, that is integrated rate equation. Next, determine the amount of product or reactant present. Okay, so suppose you want to calculate same thing, like suppose initially it was 4 moles, now it became 2 moles, how much time it took, right? So that is also you can calculate. Determine the order and rate constant of a reaction. So to find which order a reaction is and what is the rate constant of a particular reaction, we need this integrated rate equation. Okay, I hope you have understood what is the application of this one, and we will be solving numericals on this also. You will understand how does this application work. Okay, fine. So what I told, integrated rate equation will involve time also. Time as a function will also be included, and we are going to study integrated rate equation for 2 orders, that is 0th order and 1st order. Okay, so let us start with 0th order reaction. Now if you see 0th order reaction, what is there? R is equal to, rate law I am writing, rate law is R is equal to K into A to the power of N. Here N is 0, so R is equal to K into A to the power of 0, so I will get K, right? R is equal to K. So now you see here rate is equal to rate constant. There is no factor A here. So can I say that for a 0, if a reaction is 0 order, what do you mean by that? If somebody asks you what do you mean by 0 order, explain me some practically. Okay, just not the definition. Explain me in terms or define me or explain me in layman language what is zeroth order reaction. So the very simple definition here is, you can tell, sir, if a reaction is zeroth order, that means whatever you do to the concentration, you increase the concentration, you decrease the concentration, the rate of the reaction will still remain the same. Okay, for zero order reaction, the rate is not affected by the change in concentration. Getting? Okay. So zero order reaction means that the rate of the reaction is independent of the concentration of the reactants. It doesn't depend. That we can see, or you can prove that from this expression, right? Okay. Now let us see, rate law is rate is equal to K, we will get. Next, integrated rate law. So this is your integrated rate law, where it says KT is equal to A naught minus A. Okay, I'll tell you all the terms. What is this? K is, we all know K is rate constant, right? Then I told you integrated rate law also involves the time as a factor. So T is time. Okay, A naught. What is A naught here? A naught is initial concentration. A naught tells you about the initial concentration, and A is final concentration. Okay. Now what are the applications? Suppose, see, you know that initially you have started with this much and you know the final concentration. So this change has happened in how much time if I want to calculate, and I know that this is a zero order reaction and I know the rate constant, then I calculate this time. Okay, or else you know that what is this A naught, what is the time, like you have started with some amount of A naught and you know the time, and you want to calculate after this much time how much A is left, then also this you can use. And suppose you know all these three terms and you want to calculate the rate constant, then also you can use this equation, right? So it is used to calculate the final concentration or the time or the rate constant. Okay. Now coming to the units of K. So if you remembered, what was the general formula to calculate the units of K? K was equal to mole, right? 1 minus N, liter N minus 1, second inverse, right? So if I substitute here 0, N is equal to 0, so I will get mole, 1 minus 0 is 1, liter 0 minus 1, that is minus 1, and second inverse, right? Mole, liter inverse, second inverse we will get. Okay, fine. Now let us move to the graph of this one. Okay, so yes, if you see, if I draw a graph for this one, rate versus time. Okay, rate versus time graph if I draw. So I will erase this one second, just a minute. So I'll write these terms again. Okay, so if I draw the graph for, so you can see this can be a straight line graph of the integrated equation. Okay, so what are the terms? I'll write here again so that you can see when you download the notes, you can see what are these terms. Tell me. I'll write here. Okay, K is rate constant. Okay, A naught is initial concentration, A is final concentration. Okay, and T is time. Okay, these are the terms. Okay, now coming to this equation, see, this is there, KT is equal to A naught minus A. You have to draw a graph for A versus T. The graph is for, see, the graph is for KT is equal to A naught minus A. I want to draw a graph for A versus T. So this has to be my Y. Okay, so I'll bring this is to one side, A I will bring to one side, then I'll be left with KT plus A naught, right? So now I can write Y is equal to mx plus C, straight line equation. So what is the slope? Slope is minus K, negative slope, so you can see a negative slope here, right? Can you see the negative slope on the graph? Okay, now this is your Y intercept, that is where this graph touches the Y axis, so that is your A naught. Okay, and then time is on the x axis as the time, right? So this is the graph for zeroth order reaction. Getting? Okay, now let us go to some examples of zeroth order reaction. So directly students question have been asked like which of the following is a zeroth order reaction. Okay, so you need to remember these two examples, and the question have been asked in this particular example was asked in the previous year. Okay, so remember decomposition of ammonia on the platinum surface and the thermal decomposition of HI on gold surface. These two are examples of zeroth order reaction. Okay, please note down, questions are being asked for examples also. Okay. Now let us move to the first. Okay, one question is here for you. A zero order reaction in A has a rate constant of 0.003 moles per liter inverse second inverse. So rate constant value is given to you, that is 0.003 mole, okay, liter inverse second inverse. Next, how long will it take for A's initial concentration to fall from 0.1 molar to 0.075 molar. Okay, so what is the initial concentration? A naught value is 0.1 molar, final concentration A value is 0.075 molar, right? So now what I have this equation, KT is equal to A naught minus A. Okay, so if I write, I want to calculate what, how long it will take, means I want to calculate time. So time will be equal to A naught minus A. So I will get A naught value is 0.1. Okay, KT is also there. So I will write it like this. 1 second. We'll get A naught minus A by K. So I'll get 0.01 minus 0.075, right, divided by K value is 0.003. Okay, so if you solve this, we'll be getting around 8.33 seconds. So the correct answer for this question will be option number D, that is 8.33 seconds. Okay, next, coming to our next topic, that is first order reaction. Okay, so now if you see, the rate of a reaction is proportional to the first power of the concentration of the reactant R. So this we can easily see from the rate law. If you see the rate law, R is equal to K into A to the power of N, N will be equal to 1 here. So R is equal to rate into K to the power of A. That is called first order reaction. Now if you see integrated rate law equation is KT is equal to 2.303 log A naught minus A naught by A. Okay. Now what are these terms? Again I'll tell you, K is rate constant, right? K is rate constant. T, all of you know, that is time. A naught is initial concentration, right, and A is final concentration. Okay, so these are the terms that we have discussed, and this will be the integrated rate law. Now coming to units of K, again we'll try what is the unit of K. Okay, so here there's a small error, I'll correct it. Unit of K here will be second inverse. Okay, now let us try. What is the general formula of K? Moles 1 minus N, liter N minus 1, second inverse, right? And for N you need to substitute 1. 1 minus 1 0, 1 minus 1 0, so only second inverse will be left. So what is the unit of K here? I am rewriting it second inverse. Okay, coming. Next, let us see the graphs for first order reaction. Okay, I'll discuss these two graphs. So if you see, we have drawn or we have written the equation KT is equal to ln of A naught by A. Now a question may arise, ma'am, we haven't written this equation. We wrote KT is equal to 2.303 log A naught by A. So that was in terms of log. If you write in terms of ln, I'll get this equation, right? Now I want to draw a graph for this versus for ln R versus T. Okay, so how can we expand this equation? KT is equal to ln of A naught, right, minus ln of A. Okay, so what we can do, we'll take ln A to this side, okay, is equal to minus KT plus ln of A naught. Okay, now just use the equation y is equal to mx plus c. So this is y, right, this is mx and this is c. Okay, so if you see ln A, slope is minus k, again slope is minus k. What is the y intercept? Y intercept is ln A naught, right, and x axis is your t, right. So this is the graph we will be getting. Clear? Now if I want to draw the graph for that 2.303 equation if I take. Okay, so what is the equation for that? I'll write inside the graph only. Kt is equal to 2.303 log of R0 or A0. Okay, R0 is also concentration, A0 is also concentration. I need a graph for 2.3, this one versus this one, right? So I'll take this one this side, log of R0 by R is equal to K by 2.303 into T. So I can write this is y into mx, right? So y on this axis, what is the slope? Slope is K by 2.303 and it is a positive slope, right? And there is no y-intercept, so the graph is passing through the origin, right? So when there is no C, you see this equation is of the form y is equal to mx. There is no C here. If no C means no y-intercept and the graph will pass through the origin. Getting? So these two graphs you should remember. Okay, next coming to examples of first order reaction. So first of all you have to remember hydrogenation of ethene. So here also questions can be asked. Hydrogenation of ethene is an example of first order reaction. You see the reaction is like this, but the rate only depends on ethene molecule. Okay, next, all natural and artificial radioactive decays. Okay, all radioactive decays are your first order reaction. Then decomposition of N2O5 and N2O. These are also first order reactions. Okay, so simply you need to remember these examples. Okay, no more examples will be asked, these are there in NCERT, so you need to remember these examples. Okay, fine. Let us do a question now. Okay, so the rate constant of decomposition of N2O5 at 320 Kelvin is 4 into 10 to the power of minus 4 second inverse. Okay, so let us write down the value. What is this value? Rate constant. K is given to you, 4 into 10 to the power of minus 4 second inverse. If the initial concentration is given, so that means A0. A0 value is 1.6 into 10 to the power of minus 2. Moles per decimeter cube means moles per liter. Okay, that is concentration. Only 1 decimeter cube is 1 liter. The concentration after 800 seconds. So time given is 800 seconds. Concentration after this means they are asking you the final concentration, and they have already told you that decomposition of N2O5. So here you need to know that decomposition of N2O5 is a first order reaction. Even if you do not know that, then how can we know that it is a first order reaction? We can know this from the unit of K, right? For first order reaction, the unit of K is second inverse. So if we have this unit, then we can tell that this is a first order reaction. Okay, now let us substitute the formulas. K is equal to K into T equal to 2.303 log of A0 by A. Okay, so now let us substitute the values. So what is K value? K value is 4 into 10 to the power of minus 4, right? Time is 800 seconds. I'll divide this 2.303 also this side. Okay, then log of A0 value is 1.6 into 10 to the power of minus 2 divided by A. Okay, so now here I'll put equal to. So now if you solve this, okay, so once you solve this, you can calculate the value of A and you will be getting this around 1.1 into 10 to the power of minus 2. Okay, so the correct answer for this question will be option number A. Okay, fine. So now coming to the next question here. At 1000 degrees Celsius, the gaseous reaction A gives B plus C is found to be first order. Okay, one first order reaction is given. Starting with pure A with initial pressure of 120 mm of Hg. If at the end of 10 minutes, the total pressure is 176 mm of Hg, the rate constant of the reaction is given by. Okay, so this is also a very important question. Okay, see what is there? A reaction is there, A gives B plus C. Okay, and these all are gases. Okay, now what happens? The initial pressure when the reaction has just started, at that time only A will be there. So I can say that at time equal to 0, the pressure of A is 120 mm of Hg. Okay, and here it will be 0 and here it will be 0. Now at the end of 10 minutes, so I can write at 10 minutes, what will happen? This one will, some A will be reduced, so I'll get 120 minus X. How much A? See, 1 mole of A is giving you 1 mole of B. So if X amount of A has reacted, X amount of B will form and X amount of C will form, right? So I can say that at 10 minutes, this is, okay, I'll write it as pressure. Okay, so that is more clear. X may confused with So I'll write P, here P and here P. So at T equal to 10 minutes, okay, what is the total pressure? 120 minus P plus P plus P. This will get cancelled. So I'll get 120 plus P. And according to the question, what is the total pressure after 10 minutes? 176. So what is, I can say this P value? P value is 176 minus 120, that is 56, right? 56 is the P value. Then what I can say, what is the pressure of A after 10 minutes? That is 120 minus 56, right? So I'll write here pressure of A after 10 minutes. Pressure of A after 10 minutes will be 120 minus 56, right? So that is around 64. We'll get 64. Now we'll use the first order equation. So what is our first order equation? KT is equal to 2.303 log of P naught by P. So concentration and pressure can be used also. We can represent concentration in terms of pressure also. So now we need to calculate what the question has asked, rate constant K we need to calculate. So 2.303, what is the time asked? 800 seconds, log of initial pressure of A is how much? So I'll write here P naught of A by PA, right? What is the initial pressure of A? 120. And what is the final pressure of A? That is 64, right? 64 is the final pressure. Now if I solve this, I'll be getting 0.062, okay? So the correct answer for this question will be option number C, okay? So these type of questions I have given you to practice, but I'll tell you till now this question is not asked in the last PYQs, okay, but the exam level has been increasing every year, so we can expect such type of questions in future also. So you need to know how to solve. If such question comes, how you need to solve this type of question, okay, fine. Coming to next, then another term or the another important concept, that is half-life, okay. So from the word itself you can understand what is half-life. Half-life of a reaction is the time, okay, it is the time in which the concentration of the reactant is reduced to 1/2 of the initial concentration. Suppose the initial concentration is 100. Now in what time 100 will become 50, okay, that is called as your half-life, okay, and it is represented as T half. Okay, now half-life, you need to know that, half-life is proportional to 1 by A to the power of n minus 1. Okay, the proportionality T half is proportional to 1 by A to the power of n minus 1. Okay, next again we have half-life for 0th order and half-life for first order. I'll tell you the expressions directly. T half for 0 order is A naught by 2K and T half for first order is 0.693 by K. Okay, now here you need to remember that in first order the half-life is independent of concentration, okay, it doesn't depend on the concentration. The half-life of first order is independent of concentration. Now you may ask like how we are getting this value, so I'll just tell you how we can getting for 0th order. If you remember 0th order integrated rate law, what is it? KT is equal to A naught minus A, right? Now what is this final concentration? That is half of the initial concentration, so I can write A naught minus A naught by 2. We are calculating the time interval in which the final concentration is half of the initial concentration, so I can substitute like this. So if I solve this, I'll get A naught by 2 and this K I'll multiply this side, that is equal to T half, right? So in the same way you can calculate for first order also, that integrated rate law is there. KT is equal to 2.303 log A naught by A. In place of A you put A naught by 2 and then solve it, you will get T half value, okay, fine. Now let us do a question here. A first order reaction is 50% completed in 1.26 in 10 into 10 to the power of 14 seconds. So 15 T half, okay, 50% completed means T half in 1.26 into 10 to the power of 14 seconds. Now the time is required for 100% completion. See, for 50% we need this much, for 100% means it will be double of this one. So if you multiply it by 2, how much we'll get? We'll get 2.52 into 10 to the power of 14, right? So I can write 2 into T times of 50%. So that is your correct answer will be 2.52 into 10 to the power of 14 seconds. Okay, very simple and easy question. Next question. A first order reaction takes 25 seconds for concentration to decrease to half of its initial concentration. So to decrease to half means T half is given to you as 25 seconds. Now the time taken to decrease 1/8 of its initial value. Okay, it is a first order reaction. So see, this question can be solved very easily. I'll tell you a trick. It is saying that for 50%, like suppose you see initially you started with 1 mole, okay, we started with 1 mole. So from 1 to 1/2, okay, to become its half, it became 25 seconds, okay. Now from 1/2 to become half of 1/2, that is 1/4, it will again take 25 seconds, right. Now from 1/4 to 1/8, okay, again to become half of this one, it will take 25 seconds. So now you see how much we have done, 25, 25, 25. To convert from 1 to 1/8 of the initial concentration, how much time has been taken? 75 seconds, right? So the correct answer for this question will be option number C, okay. Now another important concept here, pseudo first order reaction. This is very simple thing. What is a pseudo first order reaction? See, it is a reaction that appears to be first order, okay, that appears to be first order, but actually it is a second order reaction, okay. When we see that, we'll think like that it is a first order reaction, but actually it is a second order reaction. Now what happens when do we get this one? So it happens when one or more reactants are present in much larger concentration than the other reactants, okay. So like suppose for example you have reaction between A and B, okay. Now suppose B is present in very much excess, okay. So that means what will happen? So I can write rate is equal to K into concentration of A into concentration of B. Now if you see this is 1, I'll tell that the order of the reaction is second order. But what actually happens? See, B is present in excess. That means what? If the concentration of B will change somehow, if you are changing very excess infinite concentration, you may think if little of B decreases or little of B increases, that will not affect the rate much, right, because the concentration changes not that much. So what I can say, rate will now can be written as K into A only. Now B will not be considered because it is present in very large excess, right. So now what I say, it was actually a second order reaction, but it appears to be a first order reaction. And when this happens, when one or more reactant is present in large concentration. We have two examples for this that you must remember, hydrolysis of ethyl acetate and inversion of cane sugar, okay. These two reactions are the examples of pseudo first order reaction, clear? Okay, now let us do a question here. The value of rate constant of a pseudo first order reaction depends on the concentration of the reactant present in small amount, yes, or depends on the concentration of the reactant present in excess. It doesn't depend on the excess concentration, right? So this statement is wrong. Next, independent of the concentration of the reactants. No, it depends only on temperature. No. So the correct answer for this question is option number A. Okay, fine. Now let us study one of the most important thing, that is methods to determine the order. So there are 4 ways by which we can determine the order of a reaction. First is your graphical method, second initial rate law method, third integrated rate law method, and fourth half-life method, okay. So generally questions have been asked mostly from this one, okay, but we will study all the methods so that if any question is asked, we are not stuck and we are able to solve those questions, okay. So let us start with the first method. I will be giving one question for all these methods and quickly we will understand how to do this, okay. First question. So here this one is your graphical method. So directly a graph will be given, okay, and with respect to graph you need to find which order reaction is there. So when I was discussing zeroth order and first order, you saw I drew graphs for them. So when which order log term was coming? Log term was coming in the first order reaction. So if you see this graph, by seeing the graph easily we can say that is a first order reaction, right? So the correct answer for this will be option number B, okay. Now coming to the second method, that is your initial rate method. This is from where questions have been asked regularly, okay. So now compounds A and B react according to the following reaction. So there is a reaction given to you. Choose the correct option for the rate equations for this reaction, okay. So now you see what you have to see when you want to calculate the rate, okay. You want to calculate the order with respect to A and with respect to B. You have to choose those reactions where one of the reactant is constant. Now for example, see, if I want to calculate the order, with respect to A, okay, then at that time I should consider those reactions where B is constant, okay, where B is constant. Now you tell me that in this experimental data that is given to you, this is the A concentration, this is the B concentration. Now I want to find the order with respect to A. So I have to choose out of these three reactions, I have to choose those reactions where B is constant. So you can see that B is constant in this reaction and in this reaction, right? So now I will observe this first reaction and third reaction. So what has happened when first to third? What is the change in concentration? It is doubled. I can say that here it is doubled into 2, okay, it is doubled. Now what has happened in the rate? So what change we can observe in the rate? So from 1 to 2 I can say that the rate has also become doubled. It was 0.1, now it became 0.2. You are doubling the concentration, rate is also becoming double. That means it is which order reaction? It is first order reaction, right? When you are doubling the rate, when you are doubling the concentration, rate is also becoming double, same way it is changing, then it is first order reaction. So I can say that the order with respect to A is 1, right? So here it is given 2, so I can eliminate this option and I can eliminate this option, right? Now I want to find the order with respect to B. I want to find order with respect to B. If I want to find this, then what should be constant? A is constant, okay, A should be constant. Now if you see these two reactions, okay, I want to find the order with respect to B. A should be constant. Where A is constant? Here and here A is constant, right? Now if you see what has happened here, from 0.3 to 0.6, what is happening? Rate has become double, 2 times, right? Rate has doubled. And if you see here what change has happened, from 0.1 to 0.4, rate has become 4 times, right? You are doubling the concentration, but rate has become 4 times, right? You are doubling the concentration, rate has become 4 times. Then which order reaction this is? This is second order reaction. So order of B with respect to B is 2, right? So what I will get? R is equal to K into order with respect to A is 1 and order with respect to B is 2, right? So I will get the rate law is R is equal to KAB square. So I will get answer is this one. Now if someone asks what is the order of this reaction, then it is 2 plus 1. So order of the reaction is 1 plus 2, that is 3. Clear? So by this way, by initial rate law method, what is initial rate method? Means some experimental data will be given. Using that data you need to find the order. So using this method I can say that the order of reaction is 3. Okay. Now coming to this question, that is your integrated rate law method. So here generally questions are not asked from this method, but I'll tell you how to do it. So what you are doing, you have been given with a data set. Different time intervals are given and the concentrations or different time interval is given to you. And you need to predict the order of the reaction, right? So this is a question from NCERT book. So how do we find out? See, what you need to do is you need to calculate. This is a hit and trial method. Okay, this is hit and trial method. Okay. Now what do you mean by this hit and trial method? So it means that when you are changing the concentration, you need to calculate the K, okay, and the K value should come somewhere similar, okay. So now for example, I want to calculate in the first interval here. So K I want to calculate, so 2.3, I think that it is a first order reaction, okay. So I will use the first order formula, 2.303 by 400 log of initial concentration by final concentration. I'll find this value, then I'll take another value from here to here, 0 to 800 I'll take. So 2.303 by 800 log of 1.63 by 1.14, right? Like this we can calculate the rate constant, okay. So in this way, if you calculate the rate constant for different intervals and if you are getting the same values, okay, then we can say that, and we have used the first order formula, and if you are getting the same rate constant values, then we can say that it is a first order reaction. So I'll tell you, if you solve this, you will be getting this around 4.18 something, okay, 4.18 into So if you solve this, we'll be getting around, so if you solve this, we'll be getting around 4.8 into 10 to the power of minus 4 something. Okay, so in this way we'll get the same value for all the time intervals. So in this way we can say that this is the first order reaction. Okay, so this type of questions are generally not asked, but you should know this method. Okay, now coming to, that is your half-life method. Okay, half-life of a reaction is found to be inversely proportional to the fifth power of the initial concentration. Order of the reaction is. So this is one of the previous year question. I have written that T half was proportional to 1 by a to the power of n minus 1. Now according to the question, T half is proportional to 1 by a to the power of 5, right? So now can I equate this equation? N minus 1 is equal to 5. So n is equal to 6, right? So it is a sixth order reaction. So option number B is the correct answer. Clear? Okay. Next. So now it is time to practice some PYQs. Okay, we have done a lot of questions. I have given you questions for each and every concept that I have discussed. Let us try to see how actually the previous year questions have been asked and are we able to solve them or not. Okay, so before that we'll be solving the question that I gave you in my last class. So at our last class we were discussing batteries, fuel cells and corrosion, and from that I asked you, in a dry cell which of the following is the electrolyte. So the answer for this is your ammonium chloride, okay, NH4Cl. Okay, now let us move towards the previous year question. This is a 2020 question. So for an elementary reaction, 2A plus 3B gives 4C plus D. The rate of appearance of C is 2.8 into 10 to the power of minus 3. The rate of disappearance of B at T will be. Okay, so you need to write the first, we can write the full equation, minus D. So I'll write rate is equal to minus dA by dt. Okay, 1 by 2 minus 1 by 2, 1 second, yeah, minus 1 by 2 dA by dt, then that is equal to minus 1 by 3 dB by dt, right? Then we have plus 1 by 4 dC by dt, okay, then is equal to dd by dt. Right. Now the question has asked you which value is given, C is given, okay, and B is given. So we need to derive these two, C and B, from here. So I'll write like this, minus 1 by 3 dB by dt, okay, is equal to 1 by 4 dC by dt. Okay. Now the question, so which two have been asked? Those two we need to consider, this one and this one. Okay, so now dB by dt will be how much? dB by dt will be equal to 3 by 4 of dC by dt, right? And dC by dt value is already given to you, 2.8 into 10 to the power of minus 3. So I can say 3 by 4 into 2.8 into 10 to the power of minus 3. So correct answer will be option number A. I hope everybody would have solved this question. Now coming to next. 1 liter of 2 molar CH3COH is mixed with 1 liter of 3 molar C2H5OH to form an ester. The rate of the reaction with respect to the initial rate when each solution is diluted with an equal volume of water will be. Okay, so again this question is from your rate law concept. See, initially what we have, I'll write rate is equal to K into concentration of CH3COH, right, and concentration of C2H5OH, right. Now what they are saying, initially what is CH3COH? 2 moles in 1 liter, right. So I can write that rate is equal to K into 2 moles, right, in 1 liter, and next one is 3 moles in 1 liter. Okay. Now after that what happens, the rate of the reaction with respect to the initial rate when each solution is diluted with an equal volume. So suppose I added 1 liter to both again. So what will be the new rate now? K into 2 moles is still present, but the volume now is 2 liter. Okay. Again this is 3 moles and the volume is now 2 liters. Okay. I have just added plus 1, so this is now this value. So now it is asking R dash by R you need to calculate. So what I'll get, R dash is K into, right, so I'll write it like this only, 2 by 2, 3 by 2, okay, and then R is what? K, K into, okay, 2 by 1 and I have 3 by 1, right? So this 2 3, this 2 3 will get cancelled, okay, and K will get cancelled and I'll get 1 by 4, right? So if 1 by 4 I get, that means 0.25, right? So the correct answer for this question will be option number A, that is 0.25 times, okay. Now coming to the third question here, which of the following statement is incorrect? Okay, so this question is from 2017. So molecularity is only applicable for elementary reactions. Okay, that is correct. We cannot find molecularity for complex reactions. For each single step, we can find the molecularity. The rate law of any reaction cannot be determined experimentally. The rate law can be determined experimentally, right? So this statement is incorrect. But let us see the other reactions. Bimolecular reactions involve simultaneous collision between two species. Yes, that is correct. Complex reactions can have fraction order. That is also correct. Okay. So the incorrect statement is option number B. Okay. Now see how easy definition based questions are also asked. So I have covered each and every concept from where questions can be asked. So very important concept here. The half-life period of a first order reaction is 60 minutes. What percentage will be left after 240 minutes? Okay. So let us find this one. See, half-life of a first order reaction is 60 minutes. Okay. So let us think that it was 1. Okay. We started with 1 mole. Okay. Now after 60 minutes, what will be the value? 1 by 2. After another 60 minutes, what will be the value? 1 by 4. After another 60 minutes, it will be 1 by 8, right? And after one more 60 minutes, it is 1 by 16. I need to stop here. Can you say why? Because the question is for 240 minutes, right? So now I have covered 60, 60, 120 plus 60, 180 plus 60 is 240. So the value left is now 1 by 16. Let us convert it into percentage. So 1 by 16 into 100. Right? So this you will get around 6.25%. The correct answer is option number A. Okay. Now see the last question of PYQs. For the reaction PCl5 giving you, this is 2024 question, the recent year question, that is PCl3 plus Cl2, rate and rate constants are given. So what is rate value? 1.02 into 10 to the power of minus 4, okay, and rate constant value, that is 3.4 into 10 to the power of minus 5, right? So rate value is 1.02 into 10 to the power of minus 4 mole liter inverse, and this one is 3.4 into 10 to the power 5 second inverse, respectively at a given instant. The molar concentration of PCl5 at that instant is, okay. So if I want to write the rate law for this one, R will be equal to K into concentration of PCl5, right? So I can write concentration of PCl5 as rate by constant, right? So what is rate constant value? 1.04 into 10 to the power of minus 4, and this one is 1.02, and this one is 3 into 10 to the power of minus 5. So I'll get 10.3.4. Okay, let us do it again. I just rubbed all the values. So I'll write rate is equal to K into PCl5 concentration, right? So concentration of PCl5 will be equal to rate by K, right? And the rate value given to you is 1.02 into 10 to the power of minus 4, and this value is 3.4 into 10 to the power of minus 5, right? So I can write it is 10.2 by 3.4, and that is equal to 3. Right? So the correct answer for this question will be option number B, that is 3 moles per liter. See how easy question was asked in 2024 from this chapter, right? Yes, so now it is time for you as a homework. I am giving you 2 questions. So this time I am giving you 2 questions because this chapter is really important and the concentration factor is very important. So this is your first question you need to solve. So if you have understood everything and you have tried this question and you are getting the answers, you have to comment down the answers, okay? So I can understand whether you have understood the concepts or not. So the first question here is, in a first order reaction, the concentration of the reactant is reduced to 12.5% in 1 hour. When was it half completed? Okay, this is the first question. And the second question here is, a first order reaction is half completed in 45 minutes. How long it needs 99% of the reaction to be completed? Okay, so I have missed one information to tell you regarding half-life. So I'll write two formulas here that you need to remember. Okay, so remember that T99%, okay, is equal to 10 times of T50%. Okay, please remember this value. T99.9% is equal to 10 times of T50%. Okay, this formula you have to remember and try to use this formula to solve this question. Okay, fine. Now let's have a small revision of what we have studied today. So what all formulas are there? So these are for your first 0th order reaction. Half-life formula is A0 by 2K. Integrated rate law is Kt equal to A0 minus A. Units of K is mole, liter inverse and second inverse. Now if you see for first order, the formulas, the T half formula is 0.693 by K. The integrated rate law is 2.303 log A0 by A, and the unit of K, here again I will correct it, unit of K is second inverse. Okay, so these formulas you need to remember to solve all the questions from the this concentration based, whatever questions have been asked can be solved using these formulas. So I want you to make a formula sheet and note down all these formulas and all the important concepts that we have discussed today. Okay, so yes, that was the end of part 1 of chemical kinetics. I hope you have enjoyed all the concepts and understood all the concepts in detail, and you are able to solve the questions also. So yes, if you have liked the video, if you have liked this concepts, if you are enjoying this series, then please subscribe the channel so that you can get notification about what videos are coming next, and you can prepare with us and we together can get that 60 out of 60 score in KCET 2025 examination, right? So once again I'll remind you, please join our WhatsApp channel. That is very important, so that you can get the notes of these classes, questions, everything. So the link of the WhatsApp channel will be there in the description section. Okay, so yes, and don't forget to comment down the answers of test yourself. Okay, so yes, thank you for watching once again. Keep working hard and let's crack this exam together.